Can you? I'm audible.
12 minus 12 ఎంత
Yeah, sir.
జీరో కొట్టి
Let's wait for another 2 minutes. Okay, let's get started. So in the last session, we wrote manifest file, YAML file for creating a single pod, correct? So this is the pod, right? And we are getting the pod with a single container, and container will have Nginx server running inside it. This is what we are trying to do, right? So you know how to create a cluster, right? We created the cluster. Now I'm logging into this cluster, connect, copy this command. This command will take you to the master, okay? Run in Cloud Shell. Okay, you can also open this terminal on a separate window. Right. So think that you are inside a master node. Okay. So this is the Kubernetes command, right? kubectl get nodes. How many nodes we have in the cluster? One worker node. Okay. And it says it is ready. Kubectl get pods. We don't have any pods. Okay. And to create the pod, we wrote this YAML file, right? In the last class. One is this one, pod.yaml file. So as you know, any YAML file in Kubernetes starts with the API version. This will tell what version of Kubernetes API you want to use. Kind will tell you the object that you want to create. We want to create pod. Think that you're interacting with Kubernetes, right? So I'm asking Kubernetes to create a pod. Pod has a name, and then pod has some labels. Name and labels must be inside metadata. When it comes to coding, right? Sometimes few things you need to remember. There is no other way. You need to remember. Name, label should be under metadata, right? If you practice this couple of times, you'll remember, don't you? Right? Pretty easy, right? And it's not like a C, Java kind of programming language. It's not. It doesn't have complex syntaxes. Name, labels. Here under the labels, you can give any number of labels. Label provides more information about the pod, and then comes the actual stuff, right? Specification, how this pod should be created. Pod will have one or more containers, right? So you can have more containers. That's the reason I say it is containers plural. And then hyphen means it's about first container. So container has a name, and the container will be created from Nginx. If you create a container from Nginx, anyways, what will happen? You will have a container with Nginx server running inside it. And Nginx by default runs at port number 80. So ports and then container port. It has to be container port, okay? Small c and then capital P, remember. So this is the port where your server is running on. So you assume that you have a container and then you create the container from Tomcat image, for example, right? Assume that you have a container, Tomcat, you have a container and then Tomcat is running inside that, right? You need to expose port number 8080 in that case. Okay, right. So let's create the pod. How do you execute YAML file? kubectl apply -f file and then the file name. Okay, done. kubectl get pods. If you see here, it says this is the pod name, and you asked for one, and then one is running, 1 out of 1, and it is running, right? Now you are able to successfully create the pod, right? So pod means nothing but a mission, right? It's a mission inside another. In a pod, you have another mission. People also think like this: mission inside another mission. This is a mission inside another mission. People also think that way, right? So now we have created the pod. Now, how do you access the application running inside this container? So here I'll type something like this, okay, http:// and then blah, blah, blah. So the moment you give the URL, it has to come to this particular pod, right? And then from pod, it has to go to the container. Into the container, whatever application you're running, that will be accessible here. That's how it works, correct? Okay. But I was just trying to access pod in the last class using pod's IP address, and I was unable to. See, if it is a on-premise cluster, remember this. If it is on-premise, you can access the pod from your master using curl command. Okay, curl http:// and then your pod IP 10.40.01:80. Because this pod is local to the master. If it is on-premise, you can access that. But we have the cluster inside Google Cloud, right? Since it's a cloud, they have a lot of restrictions, right? So that's the reason we were unable to access that. Okay. Now, two things. One, you have a pod with one or more containers. Inside the pod, you are running some application, Nginx application. Okay. So once the pod is created, you need to expose the pod to outside world. If you don't expose the pod to the outside world, people cannot access it. Okay. Understand the point? You have a pod. Inside the pod, some application is running, right? If your users want to access the application, you need to expose the pod to the outside world. And if you want to expose your application, right, or pod to the outside world, you need to create something called service. What's that? Service. How do you expose your application or pod to the outside world? Using a concept called service. Service is also an object. You can call it as an object. Pod is an object. Service is an object. Similarly, there are different things, okay? So using service object, you can expose your application to the outside world. How do you do that? For that, you need to create a service. You need to create a service. And for creating a service, I am writing this YAML file. This is creating only the pod, okay? And in order to make that application accessible, you need to create a service. Clear with that? Any questions about this? Okay. See this, how I have in my service. Service.yaml file. File name can be anything. It has to, but you have to Service name can be anything, but it has to end with the .yaml file. Let me save it somewhere. Okay. Let me write it, okay, so that you can understand step by step, slowly. Okay, so what are we trying to do? See, very simple. This is your Gavat cut application, for example. We store the code in Git, we take the code, we build the war file, and then we create the image, we push that image to the Docker Hub, right? And then from Docker Hub, we'll pull that image and then we'll create say 100 containers, correct? So this is environment, right? And if you want, if users want to access the application, you need to set up the load balancer right here, flipkart.com, for example. So how you will, see, that means you are exposing your application to the users using the load balancer, correct? This load balancer is called as a service. You can interchangeably, use these two, words, service or load balancer. So if you want to expose your application to the user, you need to create this service load balancer. Here we have, 100 servers, so we need a load balancer. But here in this case, we have only one part, right? We want to expose only one part. So for that also, you need to create a service. So if you want to create a service, you need to write that YAML file. You know that. How do you create a service? First step, API version v1. Services are implemented in version 1 of Kubernetes API. Then comes kind, correct? Kind. What is that you want to create? We want to create a service, correct? If you want to create a part. If you want to create a service. Then metadata. Okay. Service has a name. You have to give a name for the service. Otherwise, how do you, identify it? You may be having multiple services also. Right? We'll be having a lot of environments, no? So this is your production, say, for example, right? Flipkart.com. This is Flipkart-test.com. Flipkart-SIT, system integration testing.com. These are the testing environments. You may be having load balancer here, correct? Maybe, 10 containers. This is production, say 100 containers. And then this is the load balancer name is Flipkart.com. This is your SIT.com. Testers, access the application using Flipkart-SIT. Flipkart-test.com. This is production. So this is one service, this is one service, this is one service, correct? So you'll be having multiple services in real time. So you have to give it name for your service. Name. You can give anything. For example, I'll call it as Nginx service, something like this. Service also has labels. Okay. Right? Labels provide more information about something, right? I'll call it as, this service belongs to production environment. Okay. And this service is, running my application, which is version 1.2.3. You can give anything, okay? So when you're working in project, right, what information is helpful for everybody. So accordingly, you assign some labels. Done. You know this, right? API version, kind, metadata. Under metadata, you have name and labels. Then comes main stuff, spec. Spec specifies how this service has to be created, how you want to create this service. Okay, the actual stuff goes under spec. In Kubernetes, there are different service types. In Kubernetes, you have different service types. There is one service called node port service. What is that? Node port service. Second thing, there is something called load balancer type service. Load balancer type service. Name of the service itself is load balancer. Okay, load balancer type service, node port service. There is another service type called cluster IP service. We have 3 types of services in Kubernetes. You can expose your application using any one of these services. I'm going to expose our Nginx application, right, which is running in that pod using node port first. Okay. So you are getting a service, right? So when you have multiple services, you have to give the type. What type of service you want to create? Type node port. This is the object, right? Node port is also object, so it has to be in caps. Okay. Done. Okay. That means you are creating this. This is the pod, right? Your load balancer, say for example, it's only one part, so you don't call it as a load balancer, but something like 10, 20, 40, 50, for example. Okay. And users can access this particular pod by giving this IP 10, 20, 40, 50, and so on. So this is a service. Okay, service is a URL. Okay, endpoint to the endpoint which users use to access the application. Endpoint or service or URL simply. Okay, fine. So you are creating this endpoint. Okay, this service. Okay, fine. Under this service, you need to bring the pods also, correct? Understand the point? This is a service, right? Under this service, you need to, or in other words, you can say this. You need to attach parts to the service. You need to attach parts to the service. So assume that you have your production environment, right? This is your production. So here you have, say, 100 containers, okay? 100 containers. Load balancer has some name, flipkart.com, or some IP, 10, 20, 40, 50, for example, and then users access the application by typing this URL, correct? So this is the load balancer, right? Service. So you need to attach all these pods to the service so that when load balancer gets the request, it will give different requests to different IPs, correct? So you need to attach 100 machines, 100 pods to the load balancer. So I'm creating a service, okay, of type node port. Now I have to attach pod to the service. So when this service gets a request from the user, it will forward that request to that pod. Okay. How do you attach the pod? That's a question now. Okay. Cat pod.yaml. You can select the pods using pod labels. You can select the pods using pod label. What is the label you have here? What label we have given to our pod? If you see the pod.yaml file, labels, these are the two, right? So remember, Using labels, we attach parts to the service. So service.yaml file. Now I need to attach parts. So if you want to attach the parts, you have to use this keyword, okay? Selector. I want to select parts based on labels. Selector, match labels. What are the labels you have? Version. One is version. Second one is env. Clear with this? Let me just double check once. You don't need to give the match labels, that is not required. Let it be, let's say. Clear with this? Okay. What are you doing? Creating a service. Nothing great about these lines, correct? Name some labels. These are the labels of this service. We want to get notebook type service. This is a service, right? So you need to attach some parts. So how do you tell this service, hello service, right? You attach these parts. How do you tell? You've been using selector. Okay. This is actually not required match labels, but let me keep it. I want to see if it throws error. Okay. Selector, match labels, and then label name. This part has a label, right? Version v123 and then env. This has labels, correct? Labels. What is it? Version v1.2.3. Okay. And then env, right? Env is equal to prod. So this part has some labels, correct? So I'm telling this service, hey service, please select the parts whose labels match to this. Whose labels match to this. So what will happen? So all the parts having this label will come under this service. This is the service, right? Service. Assume that you have 100 parts. 100 parts has a label. For example, label is version v1.2.3. So if you want to attach all these 100 parts to the label, what do? In service.yaml, you have to write something like this. Selector match labels, label this. So the 100 parts have this label, right? So all the parts will be attached to the load balancer. Right. Then comes the ports. Okay. How do you, what port you will give to your users? That goes under ports. Give me a minute, you will understand, don't worry. Ports. So there is an IP address here. So URL contains IP colon port number, correct? Users also use the same thing here. IP colon port number. That's how you access the application, http colon/. So what port you want to give to the user? That is specified here. You're basically constructing an URL for the users. Ports. Port. You can give ports here. Port. 80. Target port 80. Container port 80. I'll give target port as 31,000. I'll expand, don't worry. Port, target port. Okay, we are using the node port, right? So it has to be node port. Let me use 32,000. See this. This is the pod we created. We have one pod running in our Kubernetes cluster. Nginx is running in the container, correct? Now we want to expose this part to the outside world, correct? That's what we are trying to do. So we have created a service. This section explains something called port mapping. What's it? Port mapping. This is how it works, okay? HTTP : you need to give some IP, and then you have to give one port number to the user. What is the port number I'm giving to the user? Okay, 31,000. 31,000. The moment user gives this IP 31,000, think that request will come to this IP, this pod. Request will come to this pod, right? And then I am mapping this 31,000 to 80. This one, 80. That means this 31,000 is mapped to 80. So the moment you give, this port mapping, if user types 31,000, it will come to 80. So the request has come here. End of the day, your request has to go to the container, right? So what I'm doing here, again, I'm mapping this 80 with this 80. So you need to give 3 ports, okay? One for the user, okay? The moment user types the URL, it will come to this. So 31,000 is mapped to this. That means, see, 31,000 user types, and then you are mapping this to 80, right? That means think that it comes to the pod first. Once pod comes, the request has to be forwarded to your container. So I'm mapping this 80 to the 80 which is in the container. Assume that you are running your Tomcat server here. You map it to 8080. That's how it works. So node port, remember, node port is the port number which users use. Node port is the port which users use in the URL. I'm mapping 31,000 to 80. Think that when user types 31,000, it will come to the pod. From pod, it has to go to the container. Okay. See, what is our target here? Remember this way. What is your target? Your target is to hit this particular container, correct? Nginx server. So remember that way. Target port. If Tomcat is running in your container, give Tomcat port number 8080. Target means the server that you are using. This is a port of the server that you are using in the that you are running in the container. So this is for the user. This is the server's port. This is mapping. Usually, we keep this and this same. So 31,000. When user types, it will come to the pod 80. Pod 80. If something comes to pod 80, it will go to the target port. So that's how you have to map the port. What is this 31,000? So there is some range, okay? Okay, see this. Kubernetes, it's a Kubernetes rule, okay? They say you can use any port number within this range, 30,000 to 32,767. Okay. So what I'm using here, I'm using 31,000. So you can select any one in this range. It is there in the notes. I'm using 31,000. That is in the same range, right? Summary. Asking Kubernetes to create a service. Service has a name, labels. And you know that there are different services. So you have to give the type. Then I want to attach parts to the service. So how I am selecting the parts? Using labels. So whatever label you have given, right, in pod.yaml, same label you have to give here. And then comes deciding the ports. Okay, 30,000 to 32,767 something is there, right? You select anyone. This has to be your server's port number, and usually, I mean, this is your service basically, right? The pods port it is. Okay, that's how you create the service.yaml file. Clear with this? Any questions you have before I execute this? Start pod.yaml. Okay, you know how to get the pod, right? So this will create the pod. You see the labels here, version and then env. Cat service.yaml. Same label I'm using here to select. So you need to get both the files. First, kubectl get pods. Let me delete it, okay? Let me delete it. I'll create again. kubectl delete -f pod.yaml. If you want to execute YAML file, what is that command we use? Apply, right? kubectl apply will execute it. Okay. We'll actually create the things that you mentioned in your pod.yaml file. Delete will reverse it. See, this pod.yaml is creating one pod, correct? This pod.yaml is creating one pod. If you say apply, it will create. If you say delete, whatever it is doing, it will reverse it. That means it will delete the pod. Kubectl get pods. I don't have any pods. Okay. I'm checking my cluster. Get nodes. Right? It is ready. Okay, first step, I want to create a pod. kubectl apply. Apply will create, right? Pod.yaml. Make sure that pod is running. Ready. Get pods. Pod is running. Now what we have to do, we have to attach the pod to the service, correct? So we have already written service.yaml. Well, I'm executing it. kubectl apply -f service.yaml. This will create the service. It says there is some syntax error here. Service in v1 cannot be handled as service, cannot unmarshal array into go struct field selector of type string. See this, it says, this is how you understand this. Service spec. Service spec means this one, right? Spec. Under spec, okay, service spec. Under that you have this spec, this one. Under spec, it says you have written something like this. Where is that selector? It says this is, it says there is something wrong. That means I told you, right? This is not required here. I wanted to see that error. So under selector, you should not give this. This is not supported. So that's what it says. Let me remove it. Selector. I think hyphen is not required here. Let me check with hyphen also, okay? Let's if it throws an error. See this service spec selector again. It is doing the same thing. It says, of type map string. It has to be string is what it says. So hyphen is also not required here. Let's see now. Should go fine. Ports, unknown field ports. Service.yaml file. Let me check the syntax. Just give me a minute. Okay. This is the common mistake that we make usually. I told you in the last class, YAML is indentation sensitive, right? This is the first level. First level key, first level key. This is first level key, right? Whatever we write, everything should be under spec, correct? See, service specification, right? So this is, all these things, all these lines are specifications, right? Part of specification. See what I have done? Port is actually part of specification, but I wrote this as a first level. This should be under spec, correct? That's the error it is throwing. Understand this? So service specification. Okay. So the service has a type, selector, ports. Type, this is how you select the parts using selector. Using ports, you decide what port you want to give to users. Everything should go under spec. Right. Okay, it says service is created. That means it has created the service. How do you check? kubectl get pods. I have one pod running. Get service. See this node port service. What type of service we created? Node port. And you see the port mapping. We have given 31,000, right? Is mapped to 80. kubectl get nodes. Understand the get command now? Get pods, get services, get nodes. Done. Service is created. That means your pod is exposed now. Okay, you can access this pod. You can access this pod. How do you, access the pod now? IP, right? IP. Now, what IP you have to use? Is the question correct? Remember, this IP is IP of any one of your worker node IPs. You can use, remember this, you can use any worker node IP here. That's how it works. Okay. That means your worker node IP will act as endpoint, will act as URL for your pod, for your service. What kind of service we are getting here? Node port service, correct? Node port type service. We don't use node port type service for production usually, no, because it has a drawback. For example, this worker node IP is this. For example, we have our worker node, right? This is the worker node. This is our worker node, correct? get nodes -o wide. Wide will give you a lot of extra information. How many worker nodes we have in our cluster? Get nodes, only one. Okay. Take external IP. Okay. What is that? 3469.3. 3469.3.181. Correct. http:// if you are creating node port type service, any one of worker node IP will become endpoint, will become URL. So this is like this 31,000. So worker node IP : 31,000, whatever you have configured in your service.yaml file. That's how node port works. I said we don't use node port for production because assume that you are running your application here. Assume you are running your application here. Okay. And this is the worker node IP. We have only worker node, right? That is 3469.3.181. This is a worker node IP. Okay. You gave this IP to the user. User is using that IP, and then 31,000. It'll come to this particular service, and then user is happily accessing the application. What if this worker node goes down? Possible, right? If this worker node goes down, then this IP will not work. You have to give this IP to the user, this machine's IP. What if this goes down? Again, you have to give this. That means there is no concept of fixed IP here, right? IPs will be changing. If this goes down, you have to change the IP address. And you cannot do that to your users, correct? You cannot say, hello user, today you use this IP, tomorrow you use this IP, and then day after use this IP. We cannot do that, correct? That is the reason we don't use node port type service for production. But where do we use this? We use this for test environments. We use this for test environments because node port is free. Node port is free. It is inbuilt feature of Kubernetes. Node port is free. You don't need to pay for using this node port. Basically, what we are doing today, we are creating a service. We are creating a load balancer, right? And Kubernetes has this feature called node port service. It is free. Since it is free, we use it for test environment. And it's a test environment, right? That's okay for us. Who is a test environment? Our testing team, right? For example, I give this IP to my testing team. They are using it. This goes down. That's okay for me, right? They'll again send me. They'll send an email saying, okay, DevOps team, this IP is not working. Then we say use this IP or use this IP. That's okay because it's internal team, right? Since it is free, right? We use it for test environments. That's okay, right? Otherwise, you need to purchase the load balancer. You need to pay for using it. For example, this is your image, right? We have Ubuntu, we have JDK, Tomcat, var file, right? This is our image, correct? Our image has Ubuntu, for example. Our image has JDK. This is your Tomcat. This is your code. And you have the command which starts Tomcat server. This is your Gamut card, say, for example, -image. This is your Docker Hub. So what we do, we will push this image to the Docker Hub, right? You all know this. Gamut cart -image. 1 second. And then what we do, this is our Kubernetes cluster, correct? We will pull this image in Kubernetes. This is Kubernetes master. Here, you write the pod.yaml file, service.yaml file, and things like that. That will, create given number of pods, and then it will give you the service, right? So this is the service, right? This service. You can create this load balancer using node port type service, using load balancer type service, using cluster IP service. I said node port type service is free because it's a feature of Kubernetes. Otherwise, there is one more, right? Load balancer type service, this one. This is not free. If you select this one second, let me plug the adapter. So actually speaking, service means this is what they do, okay? They take a mission, okay? It's a mission. Inside the mission, you need to install a software called load balancing software. There is a company called Citrix. Citrix has a load balancer. So the company developed this load balancing software. So you have to take a mission and then you have to install that load balancing software. What is the job of this software? Distributing different requests to different users. So this particular load balancing software is there in Kubernetes by default. So you don't need to pay. Okay. If you are using node port type service, you don't need to pay because it's a feature of Kubernetes. But node port has a drawback, right? What's the drawback? In node port, we use worker node IP as endpoint, correct? But if that worker node goes down, then IP don't work. So we don't use that for production. Then for production, with what service we use for production, we use this load balancer type service. Load balancer type service. If you mention your service type as load balancer, you know what happens? Kubernetes is running inside Google Cloud, correct? Kubernetes will go to Google Cloud. It will ask Google Cloud to create this load balancer. So who is creating load balancer? Google Cloud. If the type is load balancer type. Okay. If you mention the service type as load balancer, what happens? Kubernetes will talk to Google Cloud. It is Google Cloud who creates a load balancer for you. And who is supplying load balancer? Google Cloud, right? So you have to pay for using that, correct? You have to pay. It's not free because it is coming from the Google Cloud. So you can create the load balancer or expose your application using either node port or load balancer. Node port is free. Since it is free, we use it for test environments. That's okay. But we don't use it for production because IPs will change if the worker node goes down. That is the reason for production we use load balancer type services. And it is not free. Since it is not free, we don't use it for test. We use node port for test because why you want to pay unnecessarily, correct? So right now we created, okay, or we exposed our application using node port service and we use it for test environment because it is free. We will also create load balancer type service later for our Gamut cart application. I'll show that as well. I'll show all three, okay? Cluster IP type service, node port service, load balancer type service. I'll configure all three and then show you later. Understand now? So summary. You have an application. You want to run your application in Kubernetes. So you create a pod. That is a basic execution unit in Kubernetes. Inside the pod, we can get one or more containers. Inside the container, you run your application. Created. Okay, pod is done. Now it's time to make your application accessible by the users. For that, what you have to do, you have to create a service. I am creating node port type service here. Using service, you can expose application to the outside world. If it is a node port service, you can use any one of your worker node IPs as URL, as endpoint. And in the service, we have mapped the port. This is for the user, okay, node port. This is the port that, this is the port of the server that is running in our container. This is, pod port, okay. And this is how you select your pods under that service. That's all. So once the service is created, then now you can, using this worker node IP, you can access the application. Let's do that. kubectl get nodes, okay. But this is not showing the IP address, okay. Use this command -o wide. I want wide output. So you see the external IP. This is the one which you have to use. Okay, copy this. You can access the application using worker node IP, right? Because it's a node port, correct? Colon 31,000, correct? 31,000. Now what happens? Guess how it works? The moment I say 31,000, here it goes to pod. Okay, from pod it will go to 31,000 is mapped to 80, right? So port, and from 80 it will go to the container. So here, whatever you're running, you can access it here. It is not working because this port is not added in the firewall. See, this mission, so this pod is running in Google network, correct? I am accessing this particular pod from my home network. I connected to my Wi-Fi, right? My home Wi-Fi, right? So by default, Google Cloud don't allow other missions to connect to this for security reasons. It will not allow. Behind every network, there will be something called firewall. You know firewall? In simple words, see this. This is your Google Cloud. Okay. You have your pod here, pod or mission, whatever, right? This is my home network. This is my laptop, right? Browser. So if you want to connect to this mission, for example, you cannot directly connect. So behind Google Cloud is there, right? Behind the client, there will be something called firewall. Firewall. This guy is kind of a security guard, sits behind the network. So if any mission, right, wants to connect to this, it has to go through this person. This person has to approve. Then only the connection will go to this mission. Now what we are doing, we are trying to hit this particular pod, right? But firewall is blocking you, saying you are not allowed. So we have to tell firewall to allow any mission to connect to our pod, right? For that, you have to go to Google Cloud. Go here. You see here VPC network. Firewall is under VPC network. Under VPC, you have to go to firewall. Firewall. Take the first one, okay? Take the first one. Edit firewall rules. I'm telling you firewall now. See, right now, firewall will allow to connect to this particular pod only from this IP. Which IP? This IP. I want to say all IPs, right? Any IP. That is for anybody in the world, any from any other missions. 0.0.0.0/0 means any IP, any mission can connect to that. And what port user is using? 31,000, right? So I'm whitelisting that one, 31,000. So comma separated you can give, okay? So when user says IP colon 31,000, right? We have added the rule in the firewall saying, okay, if anybody connects to this from any IP 0.0.0/0, any IP on this particular port. If user is mentioning any IP and then this port, then allow those requests. Save it. Now you go here. 31,000. See, welcome to Nginx. That means our browser, right? The moment we give this, it is going to the Nginx server. What is running in the container? Nginx server, right? So Nginx server is responding. We have not deployed any application. If you want, you can put some code there. Okay, you can put some code there and it will show you that code here. So now it is responding. This message is coming from Nginx server running in that container, right? Okay. Let's log into the container. kubectl get pods. This is a pod, right? Inside the pod, there's a container, correct? Let's log into that container. If you want to log into a container, use this command, okay? kubectl exec -it, okay? Your pod name, nginx -pod /bin/bash. Hello Kubernetes. Please execute this command in this pod. Basically, it will give you a terminal from this pod. And that pod has only one container, so by default, it will log into that container. If the pod has multiple containers, then you have to give the container name here. ---- container is equal to container name you have to give. Since it is only one container, so I'm not giving any container name because by default, it will log into that. See, I'm inside the pod now. See, usually we say I'm inside the pod. That means you are inside a container actually, correct? You are inside the pod and then you are inside the container. See, this is where your Nginx is running. cd user share Nginx HTML. So this is where Nginx is running. Service Nginx status is running. And what code is there in the Nginx? Index.html, right? Index.html. Vim is not there. Let me install it. apt get update. apt get install Vim editor. See, let me write some code here. Assume that some HTML, or I'll just write some plain text. Okay. Faculty learning solutions, something like this. Okay. What is there in the Nginx HTML file? It has some code, right? Now you come here. Earlier it was showing this. Now It has to give the new code. Which one it is executing? Cat. Let me restart the servers. Service. Nginx. Stop. I'm logging into the pod, okay? This is how you log into the pod, right? Get pods. Nginx pod. Okay, it is not logging into the pod basically. Bash. Okay, see, I'm inside the pod now, Nginx pod. Here, where is the Nginx? User, share, Nginx, HTML, index.html, cat, index.html. Okay, I changed the wrong file actually. So now I'm in the pod, okay? So apt get update. Instead of, modifying Nginx in the pod, I modified Nginx which is in my master. Apt get install vim editor. Index.html. Something like this, okay? Now go here. It has to give the new code. Just want to prove that, you are able to access this application. I'm logging into cluster. It says gcloud command not found.
You are in Nginx server right now, I guess, Nagesh.
Hmm.
You can see that, right? Root at the Nginx pod.
This one,
Yeah,
it is already in the pod, right?
because yeah, you're already in the pod. Yeah.
By default, it took, I think, the previous shell. Why this is not working? Service Nginx status. Stop. Okay, see this. If I stop, Nginx, right? It is automatically, exiting from the pod. kubectl get pods. Logging into the pod again. kubectl service Nginx status. User share Nginx HTML. So again, it's taking this content by default. Okay, let me just
We
change it.
cannot create another HTML file, Nagesh.
Hmm?
We cannot change another HTML file. I mean, we cannot create any other HTML file.
We can, but by default, it will execute index.html. By default,
Ah,
it will the file whose name is index.
yeah, correct.
Let me change it now, okay? apt get update. So this is the index.html content now, okay? Inside index.html, I just have equality. Let's hit that. Mhm. If you want to come out of the pod, exit. Okay. Maybe it is taking from cache. Do we have index here? Slash user share Nginx. No. Cat service.yaml. Hyphen provide. This one, right? $31,000. See, it is actually working. It was a cache issue. $31,000. In this browser, it is not working because it's a cache issue. But if we open, it is working. It works. Okay. If I clear the cache in Safari browser, it will work here also. Okay. So what I've done is I'll show you. So the request is going to the pod and then this Nginx server, right? So in this the Nginx server, how do you log into a pod? This is the command we use. kubectl exec, okay, -it pod name. I'm inside the pod now, okay. Inside the pod means inside the container, okay. I'm in the container now. This is where Nginx is installed. User, we created the container using Nginx image, right? So that's the reason this has Nginx. User share Nginx, okay, HTML. So the moment you hit this URL, so the moment you hit this particular URL, right, it will go to this pod, and then inside the pod, it will, inside the pod, that means inside the container, Nginx is running, right? Nginx is executing this file. Nginx by default executes a file called index.html, okay? The file name has to be index. So whatever you have there, that is showing in the browser. That's how it looks. Correct? Yes. So that's how you can expose anything to the user. That's how you expose your Gamut Cut application or Flipkart application, anything to the user. What I'll do now, I'll quickly delete all these things, and then if you want to come out of the pod, exit. Okay, now I'm in my master set. Let me delete everything and then show you quickly, okay? And then we'll stop the class. kubectl get pods get service. This is the service which we created, Nginx service. What is this service? Can somebody guess? What is that one?
Which we applied, which we have created.
Come again.
You're talking about the Kubernetes or the Nginx service.
See, service means load balancer, right? Everybody. So we have created a load balancer, right? Of type service node port, right? Using node port type service, we have created a load balancer. This is ours. This is Kubernetes internal load balancer. Which one is that? See this. The moment you execute this, it will come to the scheduler. Here there is a load balancer. So you ask for 100 parts, for example. What scheduler will do? Scheduler has to distribute it 33, 33, 34. How it distributes the load? It has to, give pod creation request to different worker nodes, right? So here also there is a load balancer. So that is this system one. Okay, Kubernetes one load balancer. This is ours. So let me delete the service. Okay, I'm deleting the service. kubectl apply -f. This is how we created the service, right? If you have to delete it, just say delete. Delete. Okay. Get pods. Delete it. Delete pod button. Apply will create. Delete will reverse it. Right. I don't have any pods. I don't have any services. Or you can simply say SVC service. Instead of typing, you can also use SVC service. Both are same. So I have a pod. Okay. Cat pod.yaml. Remember the label of this pod. Okay. Version and then env. This will create basically one container with Nginx image. Let's create the pod. Okay. kubectl apply -f. pod.yaml, get pods, pod is running. Now we have to create a service and attach this pod to this service, and users can access the Nginx. So this is the service.yaml file, right? Service, it has a name, it has labels. Node port type service. If it is node port type service, what is the specialty? It is a free. And what will be the URL for the user? Any worker node IP. Assume that you have 3 worker nodes. You can use any worker node IP. User can use any worker node IP and access the application. We have only one part, and then that part's label is this. And then that's how we are attaching the part to this service. So this is for the user. This is the Nginx server port. This will redirect 31,000. That is from the browser to the pod. From pod, it will redirect the request to the container end of the day. kubectl apply -f service.yaml. Get pods, get services. Service is ready, right? Now, what IP will use? Get nodes. You have to use node IP, correct? Nodes -o wide. This one, external IP. This one, colon 31,000. That's how it works. And remember to, change the firewall rules, okay? Where is that? So once the service is created, go to VPC network, firewall. Select the first one, okay? Default one. Edit. You're telling firewall saying accept connection from any IP 0000/0 and then 31,000. There is one already by default. Leave that. We have added this one 31,000. Comma separated any number of comma separated ports you can add here 31,000. Save it and then you can access it. So you are clear about a pod, right? And node port type service. Next class, what I'll do, let's deploy our Gamut cart project. So that will give you a lot of clarity. Okay. And I'll also deploy Gamut cart using the load balancer type service. I'll expose it using load balancer type service. I could have directly created Gamut cart application pods. Okay. But I wanted you to understand that YAML file, step by step. That is the reason. And if you practice this YAML files, a couple of times, you'll be able to write this. Okay. Any questions for me today? You can also delete the pods like this. kubectl get pods. How do you delete the pod? You can do like this, right? kubectl. I said delete -f and then file name. Or you can also manually say something like this. kubectl delete pod name. That's the syntax, okay? kubectl delete pod name. kubectl delete service name. kubectl delete deployment name. We will discuss that concept later. anything you can delete, using this syntax. kubectl delete pod name, service name, pod name. See, deleted. kubectl get services. If you want to delete, you can delete by using that YAML file, or kubectl delete service name is the name of our service. Deleted. Get service deleted, right? Get pods. That's all. No pods. And one more thing, once your practice is done, okay, once your practice is done, you try to delete your cluster, Kubernetes Engine clusters. See, one thing to remember, there is no option to stop your cluster. There is no option to stop cluster. Only way, I mean, if you don't want the cluster, only thing that you can do is delete it. There is no stop start. Okay. You create a cluster, and then if you just leave it, see, Kubernetes service is little costly compared to other services. Okay. If you just leave your cluster with some, pods, unnecessarily, you'll burn your free credits, correct? So once your work is done, try to delete it, come next day, and then create a new cluster and then practice. So I'm deleting it. Okay. That's all for today. Any questions? Anything you want to understand more in detail? Are able to follow along with me? You need to practice Kubernetes every day. Okay. Thank you. See you tomorrow. Good night.